Welcome, everyone. Today I'm excited to introduce you to msInvader, an adversary simulation tool I have developed to help defenders refine their detection and response strategies within M365 and Azure. msInvader is a tool meant to be used by blue teamers, like SOC analysts, detection engineers, and threat hunters. It enables the simulation of the adversary techniques to generate the much needed attack telemetry that required to enhance detection and improve incident readiness. In this short session, we'll begin with a quick introduction covering key concepts and some challenges related to cloud detection and response. And finally, I'll introduce the tool, highlighting its goals, functionality, features, and the most important piece, we'll have two demos showcasing the capabilities of msInvader in action. Just a quick introduction about myself. My name is Mauricio Velasco. I'm originally from Arequipa, Peru, and that's a picture of my home city. I'm currently a security researcher within Microsoft Security AI research team. Before that, I was part of the Splunk threat research team. I'm still on Twitter, and that's my account where I share my work, other people's work, and connect in general with people. And if you're interested about the topics of adversary simulation, threat hunting, detection engineering, I encourage you to visit my GitHub where I have tools, talks, workshops of the work I've done throughout the years. Before we dive in, just a quick disclaimer. Today I'm hosting this session and releasing this tool in my personal capacity, so I'm not representing my employer in any way. All right, so msInvader focuses on simulating techniques against cloud platforms commonly targeted by adversaries. Let's talk a little bit about these platforms if you're not aware of what they are. Microsoft 365 or M365, it's Microsoft cloud-based suite of productivity tools that include email, collaboration platforms, and Office applications. It's a suite of tools, Exchange, Office, Excel, OneNote, Teams for messaging, OneDrive for files, SharePoint, etc. Its centralized storage, its ubiquity, and widespread adoption make it a common target for threat actors. We have seen both cybercrime actors and cyber espionage actors go after M365 and all the secrets it holds. Azure AD or Entra ID, it's Microsoft cloud-based identity and access management service. It's essentially the backbone of most Azure services, including 365. Without identity and access management, you wouldn't have a cloud, right? So its critical role in authentication make it a prime target. You know, if you're able to hijack the identities, then you're probably able to move to Azure resources, things like virtual machines and storage, etc. And the cloud is becoming more turbulent. If we see reports from Checkpoint or CrowdStrike, they've seen a spike on attacks. Um, Up to 75% in 2023 compared to 2022. So this is a call for action for defenders, right? Call for action. We need to deploy the proper detection and response programs for our cloud environments to avoid these type of attacks. And that comes with many challenges. And I'll mention a few ones real quick. I think that the evolving cloud techniques make it harder for defenders to understand and to adapt to emerging threats. Unlike on-premises systems where attack patterns are well documented, cloud-specific techniques can be novel and less understood by defenders. For example, if you ask a SOC analyst how to identify a suspicious process running on a Windows host, I bet most of them will give you good answers confidently. But if you ask them about identifying malicious OAuth applications with anomalous activity related to service principals, I bet the response may not be as clear. These are new topics, relatively new topics, and we need to catch up. The lack of telemetry is also a challenge. I think the lack of telemetry the lack of attack telemetry hinders teams from the building and testing robust detections. Effective detections rely on seeing how real world attacks behave in the logs. But without that telemetry from simulated attacks, defenders were often going to work in the dark or blind. For example, without the telemetry from a simulated password spray attack, how can a SOC analyst really understand what the pattern looks like within the signing logs of Azure AD? And finally, the difficulty simulating realistic attack scenarios, I think it limits SOC readiness and response effectiveness. Simulations and running simulation can help validate assumptions about detection rules, about triage process, about response workflows. Running a simulation, for example, can reveal if a SOC workflow is properly escalating alerts for certain behavior or certain actions. So it's also a good way to test if your MSP provider is doing what they're supposed to be doing, right? So for this and other challenges, I came up with the msInvader, which, as I mentioned, is a tool to simulate techniques against 365 and Azure. I think simulating techniques bridges the net knowledge gap on evolving techniques. It allows defenders to see what modern cloud attacks look like in their environment, in their SIEM products. Look at the logs. It's one thing to read about threats like token theft, but simulations give defender hands-on experience with these techniques. It also provides the ground truth or the attack telemetry required for detection, development, and validation. Without simulations, detections can be theoretical or based on incomplete information. Simulated attacks allow you to validate if rules fire correctly and with enough context. Finally, it can improve SOC preparedness or response. Running simulations can help SOCs practice responding to attacks in a control setting. It's a safe way to evaluate processes, playbooks, and overall readiness. And yeah, msInvader, I already mentioned the first 2 points. A simulation tool, its goal is to generate attack telemetry to help defenders. One thing to mention is that I've tried to implement code so that msInvader leverages different APIs, such as Microsoft Graph API, Exchange Web Services, and this, I think, provides comprehensive simulations, which we'll talk a little bit at a later slide. Okay, so at a high level, how it works, well, if you want to interact with the services within the Microsoft Cloud, you need to obtain tokens, and authentication and authorization are managed by protocols like OAuth and OpenID. Here on the right, you see the most common participants in an OAuth flow. The important thing here is that once you obtain a token, you present this token to the resource server, which could be a Teams API, it could be an Exchange API. So it's important for a simulation tool to implement these protocols and standards to obtain tokens to be able to consume services from Exchange and from Azure to be able to simulate post-authentication techniques, which is why msInvader implements these OAuth flows to obtain tokens from the Microsoft Cloud Identity platform. And obtaining tokens can help us simulate techniques for different scenarios. For example, if we want to simulate the scenario of stolen credentials, where an attacker has stolen username and passwords through phishing, keyloggers, and brute force, or malware, any technique, we can use this OAuth flow that allows us to obtain a token for users that don't have MFA enabled. So we only need a username and password. But of course, in 2024, I think this is going to be smaller and smaller. We are using more MFA now. And attackers do bypass MFA, and they implement different techniques to bypass MFA. Things like adversary-in-the-middle, token theft, MFA fatigue. And what msInvader uses is the device code flow. This allows msInvader to generate a code and ask you to submit that code for the simulated user that you want to run the simulation under, which we'll see how it looks like in a few seconds. And finally, if we want to simulate the scenario of a compromised service principal secret um, Then we can use the client credentials flow, which allows us to obtain a token for a service principal. So using these different OAuth flows allows us to simulate different attackers, post-authentication attacker scenarios. This is how it looks like for the device code flow. So if you want to simulate techniques from a particular user, like Bruce Wayne, msInvader is going to give you a code, and you go to this website, this device login site on Microsoft. You type in that code, and then msInvader is able to obtain that token for this user, and then be able to execute techniques in the context of that user. So this is how we can assume compromise and assume that this user's token or have been stolen, or this user has fallen for a adversary in the middle. Somehow, this user has been compromised, and we can execute techniques under this user. And then finally, supported APIs. I think from the beginning, it was really important for me to develop, um, to was to enable interactions with Microsoft 365 and Azure through multiple programming interfaces. And I implemented so far Graph, EWS, and the REST API leveraged by the Exchange Online PowerShell module, which is a PowerShell module used by administrators, but also by attackers. So I wanted to implement a Python client that could use that same API used by this PowerShell module. But okay, these are some of the supported techniques. As you can see, many of them are post-authentication. msInvader doesn't really support many initial access techniques. Um, you can visit the wiki. But here's what the idea of simulating the techniques used across different variations, right? So for example, if you look at the create rule technique to create a mailbox rule, msInvader is able to to execute this technique using the Graph API, using Exchange Web Services, and using that REST API leveraged for the PowerShell module. In fact, executing the same technique in different ways actually generates different logs, which we'll see on the demo. And finally, the msInvader uses a configuration file by which you can configure the simulations that you want to run. You just simply define the tenant ID and then the sessions, which is basically the assumed compromise user. So for example, we have this user that we're going to run simulations under, and this user doesn't have MFA, so we can use the resource owner OAuth flow. But if you have a user that has MFA, you can use the device code, and msInvader is going to ask you for the code, to submit the code, and you submit it interactively. msInvader updates the token and starts simulating techniques. And then you define the playbooks and then the techniques that you want to run. And of course, each technique has different parameters, which are detailed on the documentation. All right, let's move on to the demos, guys, the most important piece here. So initially, for the first demo, we're going to simulate a business email compromise threat actor. What is that? Well, it's a cybercrime exploiting deception to steal funds and sensitive data, and they have stolen $55 billion in the last decade, according to the FBI. It typically involves social engineering, email compromise to impersonate trusted entities, and facilitate fraud. BEC actors have evolved in the past 10 years from simple email scams um, to sophisticated attacks with account compromise, with persistence, with exfiltration. So we're going to simulate a relatively sophisticated attacker implementing different techniques. So what I did to create this playbook is I read a bunch of reports related to BEC actors, and I found this really interesting piece of intelligence from the Microsoft Digital Defense Report on 2024. And this report tells us that attackers, one thing BC actors do is they create mailbox rules. But they have moved on from simply creating the rule, one common rule with one common method of creating rules using like the new inbox rule commandlet from the Exchange PowerShell Online the Exchange Online PowerShell module, and now you're using the update inbox rule. I bought sorry, sorry, update inbox rules method. This method is actually supported by the EWS API, and it's a SOAP operation. So why are they doing this? Well, because it allows them to do different things. It actually generates a different log. So we'll execute that in our playbook. So this is the playbook that we're going to execute to simulate a BC actor. Let's assume that the actor performs a password spray attack. Then after successful, they log in, they start reading the user email, they try to do enumeration, read that email, um, the top emails on the mailbox. And because they want to search for specific topics, they go ahead and search emails, things like invoice or payments or contracts. So they execute this technique 2 times to search for emails that contain a particular string using the graph. Then they search OneDrive files and start downloading OneDrive files, actually, as you can see in a minute. Then they move on after the enumeration and understanding the environment by reading emails and reading files and downloading files. They move on to the persistence where they're going to create rules. As you can see here, I have 2 ways of creating rules. Why? Because one of them will be used using that REST API, and the other one is going to use that method mentioned by Microsoft, the update inbox rules. And we're going to see how that looks different on the logs. Finally, the attacker, to stay persistent, they're gonna change a folder permission, and Exchange Online allows you to change folder permissions so that one folder can be viewed by any other authenticated user on that tenant. So this could be a persistent mechanism attackers use to maintain persistence on that mailbox. And finally, a method that attackers use to move laterally is to send emails, phishing emails, malware emails to other users in that tenant. And because the email is going to look from an internal user, it's going to look legitimate. So that's going to be our final step, to send emails to other users. And this is the same playbook, but as you can see, it has more details. So it has some of the parameters that we're going to submit to the playbook. For example, when we read email, we're actually going to use the EWS method, so using Exchange Web Services. When we search emails, we're going to be using the graph, and we're going to use this keyword to search. And then when we create rule, first we're going to use the REST API, and then we're going to use EWS. So this is kind of more details about the playbook and some of the parameters we're passing. Oh, for example, when we're going to add that folder permission, we're going to change the folder permission for the inbox, and we're going to grant that default role the owner permission. All right, let's move on to the demo. So bear with me 1 second here. Okay, so here's our lab environment here, guys, where we have an Enter ID tenant with a bunch of users. We have an Exchange tenant with a few licenses here. We also have Microsoft Sentinel connected to a few apps, so we're getting the Enter ID logs. We're getting the unified audit logs from 365. And yeah, so here we have the tool. msInvader. Of course, we need an ASCII banner. And finally, we have here our simulated victim. This is going to be our victim here, Peter Parker. And Peter Parker has, mailbox with a bunch of emails. As you can see, and he also has a few files on his OneDrive. And finally, here's the simulation playbook. It's a YAML file. As I mentioned before, I'm not going to go through the details. We already went through all the steps. You can have a look at this. I think the only thing I'll call out is, for example, here, when you create a rule, for example, then you define the access method. This could be REST, or unlike the second one, this is EWS, right? So a simple parameter, changing a parameter, will execute the same technique in different way. And this time we're going to create a forwarding rule. So forward any email that has the invoice word within the body, it's going to be forwarded to this email. And then this other rule using EWS is actually going to be a moving rule, which means that if an email contains a particular word, it's going to get moved to the junk email, just like what the Microsoft report mentioned. So here are all the techniques. And of course, because this user doesn't have MFA enabled, we simply pass the username and password for msInvader to obtain the token. And finally, one thing before I run the simulation, is one thing you will notice is that this user does not have any configure rules. And on the mailbox, you see that the default role has no permissions, which is the default way of things. So, okay, so now we're gonna execute techniques, and then we're just going to pass what is the name, ph demo one. So CDM. Okay, so this is gonna start running. I'm gonna stop the video real quick so we don't have to wait and come back to it. Okay, so now it finished. One quick thing that I forgot to mention is that you can actually define a sleep time between each technique on the playbook, right? So if you don't wanna run everything, right after the other, this time each technique there's gonna be a 10-second delay between each technique. So let's go back to the logs real quick. And as I mentioned, the first technique was a password spray. So we sprayed a bunch of users, and in fact, we found a valid password for Peter Parker. So then msInvader is going to use that to authenticate to the tenant. First, the first technique was to read email using AWS. So we start reading emails, and we'll read these top emails on the mailbox. The attacker is not happy with this. They want to look for more sensitive emails. So they start searching for invoice, and they find all these emails related to invoices. They also search for contract, and they find these other files related to contract. Now they go for start targeting OneDrive and search for files. Um, and MS Invader not only searches for files and finds them, it actually downloads them. And these are the files that we downloaded for this. So we're simulating an attacker, enumerating the environment, and downloading a bunch of files. Okay, then we move on to creation of rules. So now we create a rule using the REST API. And finally, we create a rule using the update inbox rules SOAP operation. And finally, we set mailbox folder permissions, and we send emails to other users, right? This is all defined in the YAML. So if we look at the um, the mailbox here, and now we look at the rules, we'll see that there's a couple of rules created. And yeah, these are the rules for moving a email with this string in the body to the junk, and then finally forwarding rule here. Right? And finally, if we go to the mailbox, to the inbox discard, here we'll see that now this default has the owner permission, which once again means that any other user in this tenant will be able to read this mailbox inbox folder, which is a persistent mechanism that has been used by attackers. Now, of course, after generating this, the important piece and what MS Invader goal is to generate things like this, right? The logs. So these are the signing logs, and we run this, we're able to probably identify the behavior related to a password spray attack. We have the unified audit log, which is the M365 logs here, and we'll see that it's probably capturing events related to, the rule creation, and accessing files and emails being read, et cetera, et cetera. And finally, the graph activity logs here that will trigger when the graph is used. Now, here's something interesting, right? Let's look at this. So your SOC team may have a detection rule to detect when an inbox rule is created and that will forward emails to a third-party email. And this will look something like this. And this is a great start, right? Like when you identify a rule being created, forwarding emails. But because we were able to simulate the technique in a different way using this other method with AWS and update inbox rules, Um, we can also identify the logs for this other technique of creating rule. And in fact, this one will actually move an email to one folder, right? So without being able to simulate this technique in different ways, detection teams and detection posture may not be as complete as robust as we think it is, right? But thanks to msInvader, we're able to simulate both and validate our detection ideas. Great. So that's the first demo. Let's move on real quick to demo number 2. All right, so in demo number 2, we're going to execute attack more focused on entry ID and taking over a tenant via service principal abuse. So as cloud adoption grows, identity systems have become the new perimeter and are prime target for attackers. We have seen attacks by attackers like Scatter Spider or Midnight Wizard, which demonstrate how a single compromised identity can lead to an extended access and widespread impact to a tenant, particularly in this case, Entra ID and Azure. So what we're gonna use is this service principal abuse technique. This is a technique by which you can escalate your privileges by taking over service principal. We're not gonna talk too much about this technique. It has been documented by researchers, so I'll encourage you to read more about this. But this is gonna be our lab environment, and this is the attack path that we created. We created this graph with Bloodhound, and basically, we have one user who has MFA enabled, and this is going to be our starting user. This user has the AC reset password permission, so he's able to change a password for another user. And then this other user is the owner of an app registration. And this app registration is a runs as a service principal, and the service principal has elevated permissions, has the ability to grant app roles to itself and to any other. So this is the attack path right here. And of course, in order to configure my environment with this attack path, I had to perform certain configurations. And in fact, the tool I used a tool for this, and this is a tool that I actually released at BlackHat USA 2024, which allows you to explore this type of misconfigurations in Azure AD. So take a look at it if you are interested about this topic. But here's the scenario that we have. After simulating that initial access and compromising that user, first we're gonna do a bunch of enumerations, users, groups, applications, service principals. So what an attacker would do to try to enumerate the environment. Then we move to the attack, where we're gonna change the password of that second user where we have access to change the password. Then we authenticate as that second user, and because that user is the owner of that app registration, we add a secret to it, and then we use that secret to obtain a token for that service principal. And then we're gonna use that service principal to assign an app role. And this app role is gonna allow me to create a user. And by the way, let's move here. So this has more details, and this app role is a directory read write all and role management read write directory. These roles allow us to, one, create users on the tenant, but also two, assign permissions to users, or assign enter roles. So what we're gonna do with this new permission or this new app role is first create a new user and then make this user a global administrator. That's how we take over the tenant, right? And finally, we're gonna call this assign app role technique one more time, but in this time, we're gonna get a different role. We're gonna get the full access as app role. And this role is as a role for the Exchange Online API that allows us to read emails from anyone on this tenant. So we're not only going to take over the tenant, we're actually going to read secrets from users using that service principal. Okay, so bear with me 1 second to get things ready for this demo. Okay, so this is the second playbook. In this case, our first initial access or compromised user is going to be this Bruce Wayne. This user has MFA enabled. So if we want to simulate an MFA bypass or adversary in the middle, some kind of token theft, we're going to use device code. These are the other sessions that we're going to abuse, the other entities that we're going to abuse. And it has all the techniques that I described before, right? If I focus on the interesting ones, we have all the enumerations one. This is where we change the password of this user. We add a secret. We assign the app role, and these are the two GUIDs for the app role that we're gonna assign, right? Then we create a user, call it this user Majin Buu, and then we assign this user global administrator. Finally, we assign the Exchange Online full access as app, and we start reading emails from these three users. So that's the playbook. Now, before I move on, let's do something to validate something here, right? As you can see, here's the app registration that we're going to use. And this app registration only has these three permissions, and it shouldn't have more. And after the simulation, we'll see a few more. And let's bear with this. And while we're here, if we search for any Magin users, we shouldn't see any. Sorry, this is a bit slow. Okay, yes. And this is even slower. All right, see, only three permissions here. Okay, all right, we're ready for the second simulation. So now we're just gonna pass that parameter. And there you go. So now we want to simulate as Bruce Wayne. We need to go to this side. And of course, we have to interactively give msInvader access to this user. And we have that here. So we log in, and this is going to be our Bruce Wayne user. So we have to log in. Um, oh, we submit the code. This is the code. And then we're going to use a different account. And now this is we're going to use Bruce Wayne. And then we get the passwords real quick. Okay, and finally, it should work. Yes. So now we got the token, and then there you go. Start doing its magic there. Um, so I'll pause the video real quick until this finishes. But essentially, it's going to start executing all those techniques that we mentioned. So I'll pause this real quick and come back. So it finished. And if we go up and start looking at what it did, yeah, so first we ran the enumeration and using the graph, for example, it found 26 users, 5 groups, 11 applications. So that's the enumeration piece. Then it changed the password for that second user, authenticated that user, added a secret to that app registration, authenticated as that app, um, and then gave itself a different role, which was successful and successful. And at this point, it was able to create a user. So it created a user and made this user made him a global administrator. And we can validate that if we look at here, if we search for any users with this name, we'll see that user that was created. And if Entra ID portal helps us with the speed, you'll see that this user was in fact became a global administrator. And we'll come back to that since this is taking so long. All right. And then finally, after taking over the tenant, the playbook grants itself um, a new role, which is the role, the full access as app role to be able to read emails, and then uses that search principle to start reading emails. For example, it starts reading emails via EWS for this user, starts reading these 5 emails, then for Peter Parker, and then for Bruce Wayne. So leveraging that search principle and the new permissions, we start reading emails just like what a threat actor like Midnight Blizzard did. So we go back, we see that yes, this user is a global administrator. We see that initially we only had these 3 app roles, but now we see these extra app roles, the playbook. So that's it. That's the playbook that was ended up in attack, a tenant takeover, and confidential information being stolen, all from one identity um, that was compromised. So that's the end of the talk, guys. Thank you very much for your attention. And just a few takeaways from simulations. We now understand we now know more about the data sources that were generated by the execution of these techniques. It can help us in detection development. It can help us validate our security controls. Um, And it can also help us with SOC readiness to test our SOCs and our MSP providers. So that's it, guys. This is msInvader. Please visit the GitHub, give it a star. Let me know if you have any you want more features. Something doesn't work, feel free to reach out to me on GitHub or on Twitter. Thank you very much for your attention, and you all have a great rest of your day. And I'll see you on the next one. Okay, bye.